Hi, folks. So now that you've heard from Sandia about the different types of migration of Java applications into Bluemix, and she's already talked at length about application replatforming and application modernization and the different issues that are involved in those two types of migration. What I'm going to talk about in this next section is I'm going to look at the whole process of application re-envisioning and really discuss more about what it means to be building applications that are more cloud-centric. And in a lot of cases, for what we're looking at, that's going to be rebuilding an application. You can always hope that you can harvest some of your existing code, but what we're really going to be talking about are some processes for developing architectures for your applications that are going to be really and truly cloud-centric. Let's start talking about what it means to be a cloud-centric Bluemix application. Now, one of the things about Bluemix applications is that in the end, it is a set of runtimes, and you can run almost anything on those runtimes that you want. So it is entirely possible to take unchanged applications and in many cases run them on Bluemix. But that's not the way that most native Bluemix applications are written. See, native Bluemix applications are written to be what's called born on the cloud. That means that they follow a set of architectural principles that I want to take you through here for the next few minutes. The first of those architectural principles is that they're built using a microservices architecture, and we'll go into more details about what that means later on in the talk. The second is that the teams that build these applications follow DevOps principles, in particular principles like continuous integration and continuous deployment, taking advantage of a lot of the facilities that Bluemix provides. And again, as we specifically start talking about the services that Bluemix provides and how that fits into your architectural decisions, we'll talk more about how that works. And then finally, your Bluemix applications are going to be built following or in accordance with the 12-factor.net rules. And we'll quickly go through some of those and describe what those are as well. But you have to understand that it's not just that those three rules are being followed to really be a born-on-the-cloud Bluemix application. You see, born-on-the-cloud applications also have a couple of other specific things that are kind of derivatives of following these previous principles. The first is that born-on-the-cloud applications generally tend to have shorter lifetimes. New versions tend to come out very, very quickly. This is in accordance with the practices that I was talking about earlier from DevOps of continuous integration and particularly continuous delivery. And when we start talking about the dependence of your application upon different runtimes and different services, you're going to see why this is necessary. And then finally, and this is really going to get into a lot of the decisions that you have to make as how you're going to be building your application. Born-on-the-cloud applications are generally built by using the principles of what are called polyglot programming and polyglot persistence. Polyglot programming is the simple idea that when you're building an overall application that may be built out of multiple different parts that come together to form a logical set of functions, you don't necessarily have to build the entire end-to-end application in the same programming language. So you can use the programming language that's most efficient and most effective at any particular problem that you're trying to solve. Likewise, the notion of polyglot persistence is that you don't have to store all of your data in the same format and in the same way. You may be able to use SQL databases for the things that they are best at, but you also might be able to take advantage of things like NoSQL databases for things that they're better at as well. So if this is the sort of general overview of what we're looking at, I want to start going into some of the details as we start looking at the next few slides. So let's go ahead and move on. And the thing I want to begin with, as we begin looking at these questions of what it means to build architectures of applications that are going to be running on Bluemix, is I want to draw an analogy. And this analogy is one that hopefully pretty much everyone should be familiar with and should be cross-culturally applicable, because I've talked to this analogy in many different countries and in many different cultures and situations, and everyone kind of gets the idea. But it works like this. See, if you're experienced in cooking, even just a little bit, then you'll notice something very quickly, is that an experienced cook doesn't slavishly follow a recipe line by line by line. You see, usually what happens is that after you've been cooking for a few years, you start to realize that recipes are general guidelines for coming out with an outcome of a general type of thing that you're trying to build. Well, let me give a couple of examples of what I mean there, okay? Let's say that you want to build a pizza, okay? Pizzas are easy to understand. Pretty much everyone in the world is at least familiar with the idea of what a pizza is. A pizza is crust, sauce, and then usually cheese. Now, there are lots of different variations that you can do to a pizza, and different cultures and different countries do this. So, for instance, in Europe, it's very common to crack a raw egg onto a pizza before it goes into the oven, and then the egg becomes part of the pizza as it comes out. In other countries like Japan, there are many other different types of toppings that are very popular. For instance, both squid and sweet corn are very popular pizza toppings in Japan. Now, on the other hand, if I suggested either of these things to a lot of my friends in the United States, they would immediately turn up their noses with disgust at these ideas because that doesn't match what their definition of a pizza is. Well, similarly, if I'm talking about a general idea of something like noodle soup, every different culture and every different person has different ideas of kind of what noodle soup means to them. So if you're an American, that may mean Campbell's chicken noodle soup out of a can. On the other hand, if you're from different parts of China, you may have different types of noodle soup in mind that may have long noodles or may have thin noodles or thick noodles or short noodles, may have pork stock, may have beef stock, may just have tofu in it. There's lots of different possibilities for different countries and different cultures. But in the end, they're all noodle soup. Just like in the end, with all the different things you can do on a pizza, it's still a pizza. This notion of having a general idea with lots of different variations on it is something that we have found to be true of Blue Mix applications, that there are millions of different combinations of ways that you can build things. But in the end, there's only a few recipes of it. So let's take a look at those recipes and see what they look like. What we have found as we have built a very large number of Blue Mix applications with our customers, and we've sat down and we've surveyed an even larger number of these Blue Mix applications that have been built by other groups like Sandia's and by the development teams and lots of other developers from the IBM and many other companies, is that what we've discovered is that really there's only pretty much three general types of systems that get built on Blue Mix. And you see, this has allowed us to conclude that most Blue Mix applications are going to fit roughly into three different recipes. Just like you have recipes for pizza and noodle soup, you've got recipes for Blue Mix applications. And the recipes are not surprisingly matches to the general kinds of recipes of applications that we see on the cloud in general. And that is the idea of systems of record, systems of interaction, and then systems of insight. Within each recipe, what we found is that there's a repeating set of things that get composed together that show you how to combine a particular set of runtimes with a particular set of what I'm calling core services. And we'll discuss what those core services are later. Now, what I'm going to have to introduce you to is a little bit of notation, just like when you're reading a recipe in a cookbook for the first time, you have to understand, the symbols for, an ounce or 100 grams or a quarter of a cup or, something like that. I'm going to have to introduce you to some notation as to how our recipes are expressed. The idea is that things that are going to be common across all instances of a recipe, we're going to show here without brackets. But then again, sometimes you can get variations that are included in brackets, and these are optional things. Again, think about a pizza being sauce, crust, and cheese, but all the different toppings being optional. Well, the toppings would be in brackets. So if you think about the three different recipes, what we found is that the first idea is this notion of what we call a system of interaction recipe. And this is probably the most common that we've seen across a very large number of Blue Mix applications. Systems of interaction are the ones that have direct user interfaces that systems are going to be representing information to a user. A user is going to be working with that information, maybe making some decisions off of it, and then responding back. Okay? These often have GUIs that could be done as mobile applications, or they could be done as web applications, and these are different subtypes that we'll see later. But a system of interaction recipe is really simple. At its heart, most of them just have a Bluemix runtime, like a Java runtime or a Python runtime, and one or more data stores. Optionally, they can have other things added onto them too, and we'll talk about what those optional things are later. But one is the notion of a gateway, which is a way of getting data in and out of the Bluemix environment, and then sometimes a data movement tool, which is the idea of being able to change data or move data from one place inside Bluemix to another place inside Bluemix. But systems of interaction are not the only types of systems that you build. Let me skip down a little bit and talk about another common one. Sometimes, not as often as you get systems of interaction in Bluemix, you just want to be able to have an application that creates a record of something. Well, think about the idea of just making a bank deposit. Really, when you're doing that, all you're doing is create a record of something. More commonly in Bluemix might be something like, well, I want to create a survey response and store that survey response, or I want to be able to do a lookup of some information that someone has previously stored from a survey response or something else like that, perhaps in an insurance application. Well, this is the basic idea behind a system of record. And again, system of records have runtimes and data stores, and they may optionally have gateways depending upon if it has to get information into or out of, let's say, an enterprise data store. And then finally, there's the middle one, which is the notion of a system of insight. A system of insight is a way of looking at data and then being able to derive other information from that data that's not directly held in the data itself. Now, that's a little complex, but if you think about some of the applications of this will immediately become clear. Let's say that one of the things that you want to be able to do is just be able to pull up a report on all of the different responses to a particular survey that someone has done. You want to see what the most popular response is. You want to see how responses vary by a person's age or a person's zip code. That kind of reporting is a way of getting information out of the data, of obtaining insight from the information itself. Likewise, you could be doing much more sophisticated type of statistical analysis using a tool like Hadoop or using a tool like Apache Spark. All of these kinds of things are systems of insight. And so there you would combine not only your runtime and your data store, but an analysis tool like Hadoop or like Apache Spark or perhaps like embedded reporting to the runtime and the data store. And then finally, you may have a visualization on top of it, a visualization being a way of showing the user this information that has been derived out of it and perhaps displaying that as a set of graphs or building a set of PDFs or even just showing a tabular report on the screen. So if this is the basic idea, and in fact, as I've said, many of the applications that we've seen in Bluemix just very easily fit into one of those three general recipes. What we found is that that's not all there is to building and designing an application in Bluemix. It's the core of what it is. But there's a couple of other things that you have to learn too, because there's this notion of what we call ecosystem services that can be added on top of your core recipe services to kind of help the application fulfill its functional and non-functional requirements. And we'll talk about that as we get on to the next few slides. The first thing I want to look at, though, as we move on to the next slide, is a bit more explanation of what I meant by this notion of core services. Because remember that every single recipe that we looked at had at its heart this idea of a runtime and one or more core services that fit in different categories. Well, let's talk about the basic ones, data stores. So for data stores, Bluemix has a lot of different options that we'll look at in detail later for both SQL and NoSQL options. And there's going to be different situations under which you'd want to choose each of those. Earlier, we also talked about the notion of analysis tools, and I listed out a couple of examples like analytics for Hadoop and Apache Spark, but there are several other more specialized ones for things like geospatial analysis and streaming analytics and even predictive modeling, if that's the kind of information you want to try to derive out of what you've seen in the past to be able to predict the future. When we were looking at data movement, there's also the questions of augmentation and validation. So it's not just moving your data between different parts of Bluemix, which you can do with the data work service, but also you may want to translate the data, for instance, using something like Watson Natural Language Translation. And then finally, there's this question of gateways, getting things in and out of the Bluemix environment. That is where tools like the Secure Gateway and the API management systems that we have in Bluemix are going to be able to help you gain access to things that are outside. But there's also more specialized movement tools, things like the IoT gateway, which is specific to information and MQTT coming in from the IoT Foundation. There's also Twilio for being able to communicate to, let's say, phone systems and SMS texting. And then there's finally for email things like SendGrid. So all of these are just different ways of categorizing the service to allow you to think of it in terms of, well, what is the data that I'm trying to move, and how am I trying to move it, and what are my different options for being able to get this data in and out of the various places that I need to as I'm building out my recipe. Okay? So let's move on and talk a little bit more about how this whole process works. One of the things that we found is that as we started surveying all these different types of applications and figuring out how they fit into the three recipes, is that sometimes you get some common subtypes of recipes. And again, these aren't going to come as a lot of surprises to people who have thought about this in any depth. So for instance, one thing I've already mentioned is this notion that if you have a system of interaction, there's at least two different types of system interaction you might build. One would be a web system of interaction, to where you're building essentially web pages, and those may be any combination of HTML, CSS, JavaScript, any of the above, or mobile systems of interaction, which may be hybrid applications built on those same technologies, or they may be native applications that are simply communicating to a backend that's built in Bluemix. Well, if you're in a web system of interaction, you may possibly use some very specific services that are only useful in web systems of interaction. Let me give you a couple examples of that. That may be things like session caching. Session caching is really only useful if you're building Java applications that are going to have HTTP sessions. If you are going to do that and you need to do scalability, that's a wonderful service to be able to give you that ability to have your sessions survive the failure of one or more of the different instances of your application. Likewise, single sign-on, to be able to do sign-on through application protocols like OAuth is another useful thing that you might be able to use in a web system. But on the other hand, if you're building a mobile system of interaction, there's going to be some very specific services that you could use there, things like push notification or mobile quality assurance to be able to capture information about crashes of your native application, or even the mobile-specific security services that we have. So what you're starting to see is that you have that basic recipe that says, oh, I'm building a system of interaction. I need to pick a runtime in a data store. And then you may get this other layer of services around it that are specific to this subtype. Likewise, if you're doing Internet of Things systems of record, we often see that you're going to use the IoT gateway. And then finally, when you're looking at systems of insight, we've seen that there's at least two different cases of those. One of them is going to be what we're calling historical systems of insight, which are using techniques like table pivoting that are available through systems like DashDB to be able to look at lots of data and be able to do analysis of data that's coming in on the past. Whereas on the other hand, there's what we call real-time systems of insight that allow you to be able to use techniques like streaming analytics or Apache Spark to be able to process data that streams in as it happens. So this is, again, giving you an idea as to just kind of understanding the classification of your system can help you to determine what services you're going to use to build your system. And that really gets to what we're trying to show in the next slide. What we've shown, and what I've really been hinting at, is that you build up your Bluemix application architecture through layers. And the first thing you have to do is classify your application and figure out what you're building. And that is going to help you select your recipe, and your recipe is going to help you select your core services. Then, depending upon what subtype you have, like let's say a web specific system of interaction or a mobile specific system of interaction, that may help you choose a set of recipe-specific ecosystem services. And I give you some examples here specific to, let's say, mobile security, which is over here on the right above the recipes. Okay? On the other hand, though, that's not the only set of services you have. Those are really going to be specific to helping you build the functional attributes of your application. There's still the whole question of how your application gets built and how your team works together and how you move your application through the different phases of the software development lifecycle. There's also questions of how you do things like validate your application and verify the performance of your application. That's where we get to the final outermost layer of services, and we simply call these general ecosystem services. Now, to give you a couple of examples from that, let me take one from the DevOps side, which is the track and plan service. Track and plan really doesn't change the code of your application at all, and in fact, it doesn't even directly interface with the code of your application at all. What track and plan does is it helps you track different aspects of work as they move through your team so that your team can be organized to help build your application. Likewise, some of the different security services that we have really aren't about connecting into your application at all. They're about analyzing the code of your application to find out if you're following security best practices. Finally, if you look at some of the performance testing and monitoring tools at the bottom, again, they don't directly interact with the code of your service at all. But on the other hand, they may interact with the runtimes that your services are using to obtain things like logs and monitoring information. Or if you're talking about a service like BlazeMeter, to be able to drive traffic into your system for a performance test that you would then monitor the results of using a tool, a service like monitoring and analytics. So essentially what you're getting here is a layered approach to building your application. And that really gets to kind of the set of steps that you would follow to do this that we'll look at in the next couple of slides. If you think about this notion of a recipe as just giving you some hints on how to construct your application, that's giving us just enough information to be able to know where to get started. Likewise, the recipe-specific ecosystem services are going to give you the things that are helpful for one or more different subtypes of recipes that you're using. And then finally, the ecosystem services, the general ecosystem services, are going to give you things that are going to be more generally helpful for anything that you're doing. And we give several examples here, just like the examples that I gave on the previous page. But again, you want to be able to look at that enormous catalog that Bluemix provides through this lens. Think about it as being something that you're building iteratively and incrementally. And that really gets to what we're showing. You see, the approach that you need to take when looking at building applications in Bluemix starts with the basic question of figuring out what recipe your application fits in. You start at the core of that set of concentric hexagons. The first thing you want to understand is what recipe does your application fit into, and then what subtype out of the different subtypes does your application fit into. That's going to help you understand what the basic set of services that you're going to need to implement your application are. Then what happens is you build the next set of things out in an iterative way, and you only add those outer two layers of services in later iterations as you need them. So first of all, you'd start off with building your core. Now, your core may just start off with a runtime and a data store, and all you may do there is, let's say, build a unit test to build out your first microservice, and we'll talk about how to build that later, and store it in a database, and that might be enough for your first iteration. Well, then you'll want to build that out farther and farther, and it's in those later iterations that you'll determine questions like, do you need these recipe ecosystem services to implement something like, let's say, a push notification to a mobile application? Well, once you've got data in the database, you could then push it out to your mobile applications when some event happens, and that would be the next iteration of things that you would add on to it. And then finally, as your team starts growing and your code base starts growing, that's when you're going to start using these other general ecosystem services to help either fulfill some of the NFRs of your solution or to be able to essentially move your team forward in a particular way. And we gave the example of things like track and plan and monitoring and analytics, but it could also be, some of the security services or some of the other DevOps services like the DevOps pipeline that really become needed as your code base starts to grow and as your team starts to grow and you start to integrate together the activities of multiple people in your team. Okay? So what that has given you is essentially an approach to be able to break down your application and then be able to just get a handle on the vast catalog of things that are available in Bluemix for building your applications in a born-on-the-cloud, Bluemix-centric way. Now, what we're going to cover in the next few slides are going to be some things that are going to build on this basic framework that we just laid here. And what I'm going to talk about is the notion of choosing core services. So what we're going to look at are some of the differentiations between the different core services and talk about how those work and talk about when you'd want to choose one versus the other. So let's begin with the first slide in that section, which is about the whole notion of polyglot persistence. Now, earlier we talked about the basic notion of what polyglot persistence is. It's the idea that you don't always, across your entire business application, have to store all of your data the same way in the same data source. Instead, because you may have the opportunity to store different kinds of data in different parts of your application, you may not always want to use something like a SQL database for every aspect of your application. You need to be a little more open-minded and be able to look objectively at both SQL and NoSQL options because they're categorized in different ways because they serve different purposes. Well, in Bluemix, we do have a number of different possibilities for storing NoSQL databases. Now, the first one that I would want to look at, that you probably want to first consider as you're picking your different options, is Cloudant. Cloudant is IBM's high-performance JSON document database. Now, by a document database, I mean just that. It stores JSON documents. That's the primary data format that it's going to be storing. And if you don't have data that's natively JSON documents, it might not be the best match. But on the other hand, for many types of things that you're building, that's perfectly fine. One of the great things about Cloudant is we have built-in high-performance support for MapReduce, and that makes it useful in almost any type of NoSQL situation where the data that you're storing is, like I said, natively in JSON, or JSON's not a difficult thing to convert in or out of. So let's talk about some of the other situations that you might use, though. You see, Cloudant is great because it's a document database, and there's lots of situations where essentially what you're storing are JSON documents. So back to my example of, let's say you're doing a survey response. Hey, that's a JSON document. That's terrific. An insurance policy? Again, that might be a document, so that might be something that you'd want to store in Cloudant. But let's say that what you're storing is something that's a lot simpler than that. It's just something like a key value, and all you're really doing is just wanting to, say, do a lookup of a particular very short value that may be, the information that's stored that's the equivalent of an HTTP session that you want to be able to look up based on a simple key, like just a number. Well, then you're looking at a different type of database, not a document database, but what's called a key value store. And a common key value store that we often see people use is Redis, and that's available from IBM through our Compose acquisition. So Redis is a BSD licensed key value store that's really good for these kinds of simple key value lookups. So things like, just storing session information, storing information for leaderboards for games. If you think about it, rank, person, and score. That's really simple. And even just ranking documents. If again you're just trying to store things by some simple key, that's really easy to do with Redis. Now, on the other hand, if you want other options for being able to store documents, one possibility that you could look in that's very common in the open source community that a lot of people use is MongoDB by Compose. And so MongoDB is really particularly good for things like log data and things like product data management and content management, where you're storing these more kind of complex objects that you want to be able to do searches on. And so it's an excellent option for that. Now, there are other options that you have too. There's Redis Cloud and MongoLab that give you third-party Redis and hosting services and Mongo hosting services. But then finally, one of the new ones that we've got that's still in the experimental stage is a graph data store. Let's say that what you're trying to do isn't a document or it isn't a key value store, but it's naturally represented as a graph, like a social network. Well, it turns out that the Apache Tinkerpop project is devoted to being able to build high-performance graph databases like that. And our implementation of that is first surfacing as the graph data store in the experimental section of Bluemix. We wouldn't recommend it for production yet, but if you're getting ready to start ramping up and still exploring things, it's a good place to start. All right? So if these are your NoSQL options, then what are your other options that you have? Well, let's look at the next slide and talk a little bit about how those work. See, even though we've been talking a lot about NoSQL, because it is in many cases the flavor of the month that everyone wants to start with now, SQL as a technology is still something that's extremely valuable for a lot of different data storage situations. And so, especially where you need to be able to do things like unexpected queries, to where you want to be able to store your data in such a way that anyone can come up with the most bizarre query at any time and be able to run it on your data and get an answer back that's meaningful. That's really where SQL databases still shine. And so the SQL database options that we have are going to vary by not only their functionality, but particularly by the amount of scaling and multi-tenancy that they support. The first two that I would say are probably going to be the ones that you'll want to look at immediately are the SQL database service that provides a DB2 database, not a full DB2 instance, but a DB2 database that's unique to a space and is very good for low-volume applications. So again, if you want to be able to do something that's not going to have a huge amount of traffic, then the SQL database is a good place to start and may actually just meet all your needs. But on the other hand, if you do need to be able to do something that's much more scalable, and you can scale up to enterprise sizes, enterprise performances, that's where you have the DB2 on cloud service. Now, it may be true that you may not want to use DB2. You may want to use one of the other database options as well. Well, that's fine. We give PostgreSQL on Compose, and if you wanted to use a third-party tool, you could use Elephant SQL, which also gives you an implementation of Postgres. Likewise, ClearDB and the experimental MySQL service both give you implementations of MySQL. Because in the end, what we found is that much more so than the technical differentiations between the different SQL options, like MySQL and Postgres and DB2, it really comes down to just what teams are familiar with and what their DBAs prefer. And so in Bluemix, we've tried to cover all of your bases and to give you different options for each of the different situations that you might find yourself so that you can choose the right DB2 option or the right Postgres option or the right MySQL option for your particular case. All right? So if those are the data storage options, and I know we spend a lot of time on those, but those are going to be at the core of most of your applications, let's look at some of the other options that you have for some of the other core categorizations. So let's move on to the next slide and talk about this notion of storing data temporarily. Now, when you're talking about a NoSQL database, a lot of times what you are talking about is something that's storing data permanently. But a lot of times you just have data that you need to just be able to store very short periods of time. You're not going to need it for a long period of time. In that kind of situation, a caching service of some sort is really what you're going to be looking for. And there's different caching services that we provide, so let me just briefly describe what each of those are. Earlier, when I was describing the web systems of interaction, I talked about one that's specific to Java, which is the session cache service, which implements the JEE session API and works specifically with the Liberty build pack. Now, on the other hand, if you want a more generic data caching service, we provide that with the data cache service, and that gives you a very quick, very highly available key value cache that has APIs for both Java and Node, and also just has a generic REST API. On the other hand, if you want to do an open source option, you can do that using the memcached service that is a simple distributed key value cache that uses the widely available memcached APIs. Now, again, you want to make a distinction between the two options that I've looked at earlier, your SQL and NoSQL options for permanent storage, and these systems. These are not meant to be systems of record. These are meant to just host data for a very short period of time, access it very quickly, but it does need to still live in a system of record. Remember that a cache is not a database, and you should not be treating your caches as databases. All right? So if that's the ones about storing data, let's look at the other things you can do with data. One of the other situations you're going to find yourself in is, let's say that we're building a system of record, and that system of record is going to be able to have to process some data that comes in directly through a set of REST interfaces, but also may independently be getting some other data that comes in asynchronously. It doesn't happen synchronously the way REST does. It may be coming in through some other channel and may just need to be posted every once in a while. Well, that's when you need the ability to have communication between different pieces of your business application. So commonly, when we're building websites like retail websites, you may need to be able to bring back an immediate response to a user, whereas the processing of something, especially if it involves actually shipping a physical object from one place to another, may be something that takes much longer than a person is willing to wait for. Well, again, processing an order is something that could take a long time, and you would want to submit that asynchronously. Just bring back an immediate response that the thing has been placed into the queue, and then process the queue physically later. Now, there are at least 3 different options that we have for queuing types of problems that can be solved in Bluemix. The first that I'm going to recommend is MQ-Lite. MQ-Lite is a fully featured AMQP-based messaging engine with clients for Java, Node, Ruby, and Python. It is our premier solution in this space, and it's probably the best, easiest one for you to use. If, on the other hand, you're already familiar with existing AMQP-based APIs like the Rabbit APIs, you can use those too. Cloud AMQP hosts the open-source RabbitMQ messaging engine, and there's also an experimental RabbitMQ service that's available from Bluemix Labs. Now, again, all of these are simply about introducing the notion of asynchronicity into your application. I don't want you to confuse these for enterprise messaging solutions. You still would need to use an enterprise messaging solution like MQ Series, perhaps through a bridge like the Bluemix Secure Gateway for that kind of connection into your enterprise. So again, these are all internal to Bluemix and not about connecting between things that are inside Bluemix and things that are outside Bluemix. Okay? So let's move on to the next section and talk about these different types of gateways that we have for communicating between what is inside Bluemix and what is outside Bluemix. Now, the first one that I wanted to mention is, again, the last one that I cover here on the list, which is the Secure Gateway. What the Secure Gateway service allows you to do is to open up a secure portal between resources that are behind your corporate firewall and things that run inside Bluemix, and it's very limited in its scope. It only allows you to connect very specific things that are behind your firewall, and it's built using a set of different IBM technologies that we've had around for a very long time. It can be done based on the data power appliance that you may have running in your corporation, or maybe based on a Docker or VM solution that we have that you can also host into your enterprise, but it's all based on a secure tunneling technology that is, again, very limited in scope and what it can connect to and how it can allow those connections to come through. That is probably the best option for being able to do something like connecting to an enterprise data source. There are other options you have, though. If you want to, again, bridge into communications that use voice and SMS, that is exactly what Twilio would be for. If you want to send and receive MQTT messages through the Internet of Things Foundation, that is what IoT platform would allow you to do. And then we've already talked about SendGrid and using it as a gateway to be able to bridge email back and forth between your applications and your email infrastructure. Well, then there's the question of API management. API management is allowing you to create Bluemix services from existing APIs in your enterprise, and then to be able to manage the use of those APIs. So it may be that you're creating new APIs in Bluemix that you want to then expose to other Bluemix applications, or more likely you have existing things in your enterprise that you want to be able to gain access to through the secure gateway and then expose to your Bluemix applications through API management. And that's a really common situation that we see time and time again. Okay, let's move on to the next slide and talk about this last question of sort of, well, how do I get my data in and out, and how do I change my data as it flows between all these different options for storing data and dealing the different things to it that we've seen? Well, there's several different options you have here based on, again, the type of data that you're actually wanting to manipulate. Let me give you an example. A really common situation that we see lots of times in retail applications or in applications that involve people searching for physical objects is one where you're going to have to convert a GPS coordinate to a physical address or vice versa. Well, that's where the Pitney Bowes geocoding and reverse geocoding services come in. Now, on the other hand, if it's actually a physical bulk data load you need to be able to move, let's say you want to be able to move data out of Cloudant and into DB2 or vice versa. That is exactly what DataWorks allows you to do. It allows you to move data from one database to another, and it also has some validations built into it. Like, for instance, one of the things it can do is validate postal addresses. So it may be that the first thing you do is you convert your GPS coordinate that you're getting from your mobile application into a postal address, which you would then want to validate to see if that's an inhabited postal address. Okay? The next thing you would want to do then is think about, well, what about converting not just from one type of data to another type of similar data, but perhaps converting the content of your data from one natural language like English to another one like Mandarin Chinese. That is what Watson Natural Language Translation allows you to do. Okay? Now, then finally, while we're already talking about this idea of geolocation and, converting from GPS coordinates to physical postal addresses, one of the other things you might want to do is think about that in a much smaller scale. What about inside of a building, inside of a sports arena or inside of a retail mall? That is what Presence Insight allows you to do. It allows you to geolocate a device inside a very small bounded region like that, and then allows you to write your applications to provide that user with venue-specific information based upon where they are. Now, on the other hand, if you're moving within a larger bounded area, let's say something the size of a park, or something the size of a neighborhood, that's where geospatial analytics would enable you to be able to get MQTT notifications whenever a device moves into or out of a different bounded area like that. So in any cases, what you really want to do is you want to think about these as being pipes or filters in a data pathway. They're not going to be the end state for your data. They're different ways of getting data from one place to another or converting it as it flows down the pipeline. So again, think about this notification coming from your mobile application that is encoded originally as a GPS coordinate. You would flow that into the Pitney Bowes service. You would get a different piece of information out in terms of a postal address. You would flow that into, let's say, DataWorks to validate it. You would get back, a validated address out of that, and then you may even flow that into something else or even just store it in one of the database options that we've looked at. That's what we mean by a pipes and filters architecture. It allows you to just think about how you structure the various pieces of your application together to be able to take advantage of these kinds of services. Okay? And with that, we are done with our survey of all of the different types of services that you have when you're building applications with Bluemix. And we've also, at this point, finished out our discussion of what it takes to really move your applications and re-architect them from their existing designs and the existing assumptions that they have into the new assumptions that a born on the cloud architecture are going to have, to where one of the biggest changes is you're going to be able to take advantage of all these services. You're not going to have to write everything on your own, and that is going to make you much more productive, and it's going to make your jobs just an awful lot easier. So with that, we're going to close things out, and we thank you very much.